This week on the show, we have Dragonfly BSD release 5.2.1 available, BPF kernel exploit write-ups, remote debugging the running OpenBSD kernel, which should be interesting to some users. We have an interview with Patrick Mooney. The FreeBSD buildbot setup in a jail is what we also explained to you. Dumping your USB traffic and 5 years of gaming on FreeBSD in this week's episode of BSD Now. BSD Now, episode 248, Show Me the Mooney, recorded for the 30th of May, 2018. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And we have a great episode prepared for you this week, starting off with the headlines, as every week, with the new Dragonfly release. There is 5.2 out with an interesting part because Hammer 2 is apparently stable now.
Well, in particular, that the installer supports installing that as the base file system.
So they trusted enough to put the system on it. So this is actually a point release. This is 5.2.1.
Yep, point release that follows the 5.2.0 from April. The big ticket items they have are their Spectre and Meltdown mitigation support. This is automatically enabled on all Intel CPUs, and the Spectre mitigation must be enabled manually by a sysctl if you desire, using the sysctl mockdep is in machine dependent Spectre _mitigation and Meltdown _mitigation. And then Hammer 2 has now received a very large amount of bug fixes and performance improvements, and they say we can now recommend Hammer 2 as the default root file system in non-clustered mode. And cluster support is not yet available. There were also some improvements to IPFW3, their fork of the FreeBSD firewall. They implemented a state-based redirect. So instead of using libalias to rewrite the packets, they can actually just do the redirects as dynamic state rules. And they also now made it support all different types of ICMP packets, up to the 40 different types instead of just the old common types that you might encounter. Mm-hmm. And then they have some improvements on their graphics stack. The DRM i915 kernel driver has been updated to support Intel Coffee-like GPUs. That'll be, I guess that's the like a Lenovo X280, I think, is what that is. And added 24-bit pixel format support to the EFI frame buffer code, so you can get all of the colors. And significantly improved the FBIO support for the SCFB XOR driver, so that if you're not using a graphics driver at all, this allows the EFI frame buffer to be used by X in situations where you can't get the GPU to work.
Oh, okay. It's a fallback.
They also partly implemented the FBIO blank ioctl so that you can have the driver turn your monitor off to save power.
Also good. Yeah, so it seems small, but again, this is mostly mitigating Spectre and Meltdown. And if you want to learn all the details for the changes since Dragonfly 5.0, there's a whole longer list way down at the bottom. But you can grab the latest checksums to compare whether you downloaded the proper ISO or there's nothing missing. And then they provide instructions how to update your system using the, just git and make build world, the usual cycle. Okay, that's the Dragonfly news that we have. Again, we get seldom news from Dragonfly itself outside of the new releases. So if you have something written about or found something about Dragonfly, we want to know about it, and we can cover it in a future episode. But next up,
so this is a note on a GitHub page. This is an exploit for the PlayStation 4 4.55 using BPF. So they say, note, while this bug is primarily interesting for exploitation on the PlayStation 4, the bug could also potentially be exploited on unpatched versions of FreeBSD if the attacker happens to have read-write permission to the /dev/bpf device, which is normally root only by default, I think. Or if you want to escalate from root user to kernel code execution using that device.
Okay. Oh yeah, there's
as such, they've published it under the FreeBSD folder instead of the PlayStation 4 folder of exploits.
Okay.
So they say, welcome to the kernel portion of the PlayStation 4 4.55 firmware full exploit chain writeup. This bug was found by a user named QWERTY and is fairly unique in the way it is exploited. So I wanted to go do a detailed write-up on how it works. The full source for the exploit can be found with the link there. And I previously covered the WebKit exploit implementation for the userland access, which is written up over here. So they ask, was this a FreeBSD bug or a Sony bug? And why not both? See, interestingly, this bug is actually a FreeBSD bug and was not, at least directly, introduced by Sony code. While this is a FreeBSD bug, however, it's not very useful for most systems because the BPF device is owned by root and has the permissions 0600, meaning that you have to already be root before you can touch the device. Though it can be made, or it can be used for escalating from root permissions into the kernel mode code execution. However, let's just take a look at the makedev call inside the PS4 kernel for the BPF, which they took from a PlayStation 4 4.05 kernel dump. And they say, we see that UID 0, or the UID of the root user, getting moved into the register for the third argument, which is the owner argument. However, the permissions bits are being set to in hex 1b6, which is the octal for 0666, meaning anybody can read and write to the device. So that means any user can open BPF and have write permission to it. I'm not sure why this is the case. The person who found or wrote the exploit speculates that perhaps the BPF is used for giving games access to the network card to gaming across the LAN and so on. In any case, this was a poor design decision because BPF is, usually considered quite privileged because it's its own virtual machine language running in the kernel.
It can do a lot of stuff.
Yeah, it should not be accessible to a process that's completely untrusted, like, say, WebKit, your web browser. On most platforms, the permissions are locked down to only the root user. So this one takes the form of a race condition. So they do a little bit of background of what is a race condition. This class of bugs is abused in an exploit known as a race condition. Before we go into the specifics of the bug, it's important for the reader to understand what race conditions are and how they can be an issue, especially in something like the kernel. Often in complex software, such as the kernel, resource can be shared or available to everybody. This means other threads can potentially execute code that will access some resource that could be accessed by another thread at the same time. What happens if one thread accesses this resource while another thread does it without having exclusive access, then a race condition can occur. Race conditions are defined as possible scenarios where events happen in a sequence different than the developer intended, which means an unintended behavior. Kind of think of you're reaching for the last cookie and suddenly it disappears because somebody else took it.
Yep. It was faster.
Rather, you already picked up the cookie and you're about to put it in your mouth and it disappears because somebody else took it. You're like, where's my cookie?
Yeah, that's a good explanation.
In a single-threaded program, it's not an issue because execution is linear. In more complex programs where code can be running in parallel, however, this becomes a real issue. To prevent these problems, atomic instructions and locking mechanisms are introduced. When one thread wants to access the critical resource, it attempts to acquire a lock. If another thread is already using the resource, then generally the thread that wants it will have to wait to acquire the lock until the other thread is done. each thread must release the lock to the resource after it's done. Otherwise, everybody will sit there waiting to get access and will never get access. Sorry. Fixed. There we go. Sorry. While locking mechanisms such as mutexes have been introduced, developers sometimes struggle to use them properly. For example, if a piece of shared data gets validated and processed, but when the processing of the data is locked, then the validation is not, etc. There's a window between when you check it and to see if it's valid before you start working on it, and when you take the lock to actually work on it, and in that time, it could have become bad.
Yep.
Parallel programming can be difficult, especially as a developer. So you also want to factor in that you don't put too much code in between locks and unlocking because everybody else has to wait while you're doing that.
Yeah, that's the problem with locks, that they slow down certain things, but they're important nevertheless.
The article goes on to explain what packet filters are and why BPF is a thing. And then it talks a bit about the out-of-bounds write primitive that they use in BPF here to actually replace other data that you're not supposed to be able to touch. So now they show how they actually exploit the race condition. If we look at where the instructions are copied into the kernel, we'll see that it runs BPF validate, and it happens. It will run immediately, meaning at this point we cannot specify a value that allows an out-of-bound access. But because they don't have a lock on it then, you can have it validated, then replace it with the bad one, and then it'll run it because it passed the validation. And it might take many tries before you can actually get the timing just right, and it might not be 100%, but you can just sit there, keep trying, and it'll reject it when you're not fast enough, and the exploit will run when it is.
Yeah, and that makes it possible to... Is that the exploit that actually made it possible to install other operating systems on the PlayStation 4?
This is a newer one, but they've used many different exploits to do that.
Yeah, I wonder what the PlayStation 5 is going to run, but we have to wait a couple of years, I guess, to see that.
Yep, and there's some pictures and more stuff talking about how all of this works and showing you how the exploit works. But it's a bit too long for us to do it all.
There's assembly and C code and all the details for people who want to dig into it.
Yeah, and they actually show how Sony tried to patch it and how it didn't work and so on. So they say, in conclusion, this is a pretty cool bug to exploit and write up. While the bug is not incredibly helpful to on most other systems, as it cannot be exploited by an unprivileged user, it is still a valid method of going from root into the kernel. I thought this would be a cool bug to write up, plus I love writing these type of things anyway, as the attack strategy is fairly unique, using a race condition to trigger an out-of-bound write to the stack. It's also a fairly trivial exploit to implement, and the strategy of overriding the return pointer on the stack is an easy method of learning security researchers and how to do it. It also highlights how, while an attack strategy might be old, perhaps this one being the oldest that there is, this can still be applied to modern exploits with a little variation.
Yep, it's not just limited to that one or to that system.
Yep. This week's episode of BSD Now is brought to you by IX Systems. Head over to ixsystems.com/BSDNow and check out their ultimate guide to buying a new server for open source.
Yes, because you might be in need for a new server that does something for you, like storage or runs the database or some kind of web application, and you're not sure whether you need more memory or more CPUs to make that run just smoothly. So that's what you have to ask IX Systems, because they know what kind of profile, let's say, your application might have, and they can tell you which components work best in this case for that specific application or use case. from the biggest storage servers like the TrueNAS all-flash servers to the relatively small FreeNAS Mini for your home or desktop use.
You need something this big for home? Sure. This big for home? Sure. This big for home?
They can scale up, yeah.
Now you're acting like me. Or, then you get into work. Do you rather need a short depth 1U just to get something done? Or if you need, a whole rack full of gear, whatever it is, they have the right stuff for you.
Yeah, and it's custom built, and they will test it before they ship it out, because chances are that on arrival, that one disk is dying and you can't start. That's why they do the testing before that. They do the burn-in test to make sure that the disks are not dying in the first hour or two.
Because every machine is custom built, you always get exactly what you need. And because they put the time into validating the system before they send it to you, it means you don't have to mess with failed disks or RAM that wasn't quite right or whatever, because they burn them in for 3 days before they ship it to you. And that means that all the little bugs are going to be worked out before it goes out the door. And that adds up a lot. And you can tell the level of care they take when you get the machine, and the drives are shipped in a separate box that is got a level of padding you just were not prepared for.
Yeah.
And so it does two things for you. A, the server's a lot lighter when you don't have the disks in it. So putting it in the rack is much easier that way. And B, the hot swap trays were not meant for traveling the hard drive in it, right? Like if you just fill the machine with hard drives and ship it, those hard drives are probably not going to have a very fun ride. Whereas in the special IX packing that the drives come in, it's much nicer. And they've taken the effort of putting all the screws in and stuff for you already. So you just unwrap them and stick them in and you're good to go. I cannot express how happy I was when I found out I didn't have to sit there and put 144 little screws in the box of hard drives before I started using them.
A lot of fiddling and one fell down and I can't find it anymore, and things like that. That's what makes you appreciate the extra service they put on that for their customers.
Yeah. And if you head over to their blog, Michael Dexter has an extra post up there recently trying to help you better understand what's going on with ZFS performance, and talking about using tools like Top and gtrace and flame graphs to understand what's going on, but also taking a book or a page from Benedict Gregg and looking at the time scales of system latencies. If you consider that one CPU cycle is, say, 1 second, that means every time you want to get some data from memory, RAM, that's 6 minutes. If your scale is that one CPU cycle is 1 second. So when you think about it, your ARC, the primary cache of ZFS, and your RAM means it takes 6 minutes to go get some data from there.
That's a long time.
If it's in your L2 ARC, because it's on an SSD, then that's somewhere between 2 and 6 days, depending on the amount of money you spent on your SSD. Again, going back to IX helping you pick the right kind of SSD. Your write cache wants one kind, your read cache wants another kind, and if you just have SSDs for the pool itself, then that's a third kind. But if you have to go to your spinning disks, that can be anywhere from 1 to 12 months.
Yep. They work in milliseconds.
If you have those power-saving drives in your NAS, then they can take longer. And it depends on how fragmented they are and all kinds of things, because you're physically moving an actuator to a spot on the disk and reading some data. And then if your data is split up across a bunch of different spots, then you got to move the head back and forth and back and forth. And, you can have 5,000 RPM, 7,000, 10,000, or 12,000 RPM drives.
It's, still not so fast as compared to the other layers above that. So but sometimes you have to go down there because they have much more capacity, and it's good to know about these different access times.
Yep.
And of course, IX systems will optimize for the performance that you don't have to wait that long when they built you a system for your purpose.
Mm-hmm. So moving on to our next story.
Yep, we have remote debugging the running OpenBSD kernel.
Sorry, I said it over W.
Yeah, so for the people who always wanted to know, how do I remotely debug this OpenBSD system over there? This is the article for you. So first they explain the problem. It's basically, a few months ago, I tried porting the FreeBSD KDB along with its GDB stub implementations to OpenBSD as a practice of learning the internals of a BSD operating system. The GDB code in both FreeBSD and OpenBSD looks pretty much the same, and the GDB remote serial protocol looks very minimal. But sadly, I got very busy and the work is stalled, but I'm planning on resuming the attempt as soon as I get the chance. But there is an alternative way to debugging the OpenBSD kernel via QEMU. What I did below is basically the same with a few minor changes, which I hope to describe it as best. So first of all, you install OpenBSD on QEMU, which isn't that difficult. You basically start the QEMU image, create your raw image disk, like 5 gigs. That's totally sufficient. And then you configure your little QEMU system, provided a bit of RAM, and tell it where the drive is and where your OpenBSD install disk is located. Then you basically start up and install and then provide a custom kernel, because to debug the kernel, we need a version of the kernel with debugging symbols enabled, and for that we have to recompile it first, because the default kernel doesn't have those for performance reasons. The process is documented at building the system from source. That's also provided here for people who want to look that up. And then we copy the BSD kernel to the guest machine and keep the bsd.gdb on the host to start the remote debugging via GDB. So that's done here. vn-config, and the disk labeling is done. And once that's done, you mount that thing and do it a vnc-config-u vnd0. So now the actual remote debugging is done with being able to boot the guest with the new custom kernel. And remember that the -s argument enables the GDB server on QEMU on localhost port 1234 by default. Of course, you can change that if you don't like that port, or it's too common. You maybe have something else listening on that, but it's just a simple setting on the QEMU system. And now you can finally attach to the running kernel. You go to GDB, obj/bsd.gdb, and then you can happily jump around and create, breakpoints and jump to certain threads and things like that. And it's all remotely. Yeah, and I think it's basically generally applicable to other BSDs, isn't it?
Yeah, if you're using QEMU, you can debug anything, basically.
Yep. Okay, speaking of debugging, we have a good amount of debugging in our interview coming up. This week we have Patrick Mooney with us here in an interview. He's a software engineer, and if you remember the Ryan Zazeski interview, he recommended us we should have an interview with Patrick. So here we are. Welcome to the show, and we ask everyone who's here for the first time on the show, how did you get first introduced to Unix?
Thanks for having me. In terms of my introduction to Unix, I've been a Linux user for a long time, since I was in high school. But if you want to talk about strictly Unix, I messed about with FreeBSD some when I was in high school, a little bit while I was in college. I didn't ever really use it in a huge amount there until I got to my first job out of college at General Mills. I joined the Unix team there, and that wasn't a FreeBSD shop. It was a full HPUX shop. So I got to use old Big Iron Linux there for a while. That was quite the experience. But to be honest, my experiments with FreeBSD prior to that kind of prepared me for that. It is easy to, if you're using only Linux, get used to all the GNU-isms and kind of get comfortable in the way that someone gets comfortable on Windows or OS X or anything like that.
Yeah.
So being ready to find things that weren't on Linux on HPUX using, having experimented with FreeBSD there helped quite a bit. So it softened the blow of, like if config doesn't work as I expected, or these tools are totally missing, or it's just regular vi instead of vim, things like that.
Yeah. It's usually coming back in other operating systems or distros. Oh, I've always done it with this one specific command or tool. What's the new command I have to learn now?
Oh yeah, totally. And to go from the online communities of open source to the closed proprietary systems of HPUX in that case was a surprise there for sure.
And how did you end up getting into Illumos?
Getting into Illumos was actually when I came here to join it. It was, I had been certainly aware of Solaris and the work that had been done there. I was pretty disappointed to see when Oracle purchased Sun. I was still at General Mills at that point, and had been kind of hoping that maybe we would look at Solaris as an alternative to HPUX, but when Oracle swooped in, that sort of ruined that thing there.
Yeah, that and many other things.
Yeah, yes. It was, I think, a disappointment for a great many people. But once I'd come to join, I started using SmartOS here and really came to love the system and the choices that were made. And I think for me, the way that SmartOS is set up kind of is a lot easier for me to use. I know back when I was in college, I had some friends who ran kind of an old Solaris system. And I remember them griping about you had the Sun Studio compiler and IPS packaging, and there was all of this stuff that was kind of really inaccessible to a normal person, or at least someone who's just playing around with this stuff. Having access to things like package source in joint zones and using regular GCC, and it certainly made it a lot easier for someone coming from kind of the general open source community to come in and use it.
Well, speaking of open source community and so on, how did you actually get started contributing to open source projects?
Sure. So while I was at General Mills, I spent quite a bit of time on the Unix team there. And then sort of during my tenure there, it became pretty clear that HPUX on Itanium was not going to be the platform that would carry them forward as a business. Certainly some of that was Oracle's announcement that they were going to cease supporting Oracle on Itanium. So when you've got these critical business systems, you need a supported platform. So I was part of the effort to move kind of the entire enterprisey business systems from HPUX onto Linux was then our choice there, which was very nice. I mean, it opened up a lot of room to actually start using open source technology in a more expansive way than was on HPUX. It certainly wasn't totally absent on HPUX, but once you move to Linux, it's pretty easy there. So it was nice to, when I was debugging a problem, to be able to go, oh, this utility, this tool, this piece of software isn't acting how I think it should. What does the source say? You can stare at a manual all day long. The manual might be wrong. Who knows? But if you go to the source, that's how it's working. So I kind of got in the habit of doing that sort of thing. I contributed small bug fixes here and there to things that I encountered, or I needed a small feature for this thing. It was still largely an ops role. I went to school for computer engineering, but my role at General Mills was largely ops. I wasn't writing a lot of software. But as we were rolling out this Linux environment, one of the things that I wanted to do was get better Active Directory integration with our enterprise Linux environment. There's some software out there that does this today in terms of SSSD or these things that'll map AD into traditional users. But I don't think that any of them were designed with corporate Active Directories in mind, where you've got a gajillion users and a gajillion groups, and it'll go, oh, I'll try and enumerate all the groups this person's in, and logging in will take half an hour.
Mm-hmm.
Yeah.
So I was trying to write some bespoke tooling for those things. And I ended up finding a library called LDAP.js for doing LDAP service and client stuff in Node.js. And I wanted to do some things with that, and there were some kind of deficiencies or some bugs that were preventing me from doing things that I wanted to with Active Directory. So I started contributing back to that project, and it turned out that project had been written by someone here at Joyent, and that's actually how I got my job here at Joyent. Was I was contributing patches back, and they liked the software that I was helping improve. So that's how I landed here.
Oh, okay, that's the connection. Yeah, yeah. You touched on it a little bit already. So, what sort of things have you worked on in the past?
Sure. So I covered some of the things that I did while I was at General Mills. Prior to that, when I was in university, I did web development. Back then, it was PHP and MySQL and CSS and JavaScript that are nothing that resembles what people are doing today. It was I to support IE 5.5, and it was.
Yeah.
I'm glad to be done
hacks.
with all of it. Oh, it was disgusting. So that's what I did in university. Came to General Mills. Was in the HPOX administration. Spent some time in network. Did the Linux project. Came to Joyent. When I initially came here to Joyent, I was working on mostly the LDAP.js stuff. I worked some in with a key value store, did kind of upstack stuff. But pretty shortly after I landed there, I got the opportunity to start working on LX-branded zones, which I think you've talked about when Brian was on, but that was it's our technology for running native Linux binaries in a SmartOS zone. So myself and a few other people worked pretty hard on that for several years. Mm-hmm. That was kind of my focus with some other forays into other operating system things. And then most recently, I landed on the Beehive porting project.
Yeah, I guess that's what we're here to talk about. So can you tell us a little bit about what attracted you to Illumos so much? You said you really liked the way it was put together.
Yeah, I can't claim that I was too familiar with Illumos or OpenSolaris before I came to Joyent, but it's certainly been a process of discovering things that I like about it. So, I think one of the most simple demonstrations of that is some of the P tools, the process tools. And kind of just the rigor built around them. So, you've got tools like, PARGs or PNs that'll just print the arguments or the environment to something. But kind of one of my favorite little tools that, like, it doesn't seem like much, but I've found it hugely useful, is pstack, where you just walk up to a process and say, like, what are the stacks of running threads in this process? And it doesn't seem like much, but it's way easier than, if you've got a process that's like wedged and doing something, you don't know what it's doing, you can just like walk up to it and ask what it's doing. And because like all of the binaries are built with their full symbols and they're built with frame pointers, so you can easily traverse the stack. It's like this super simple thing to say, hey, like, what system call, what function am I in? Like, I've got this bash script that I don't know what it's doing. And like, without doing like, even for a system administrator, you can just walk up to a process and say, like, what is this thing doing? And because it's in some function and you've got all the names there, it's just like this simple little thing in terms of observability that makes all the difference in the world. So, all of this stuff is designed to be observable, designed to be correct. And that's something, you see that same care in the kernel and the same care in the way that it's developed. And that's something that I've really come to appreciate.
Yeah. So that's a great segue into the next question, actually. How did you get interested in and started with the systems development?
It's been kind of an interest of mine for a long time. I'm interested in systems in general. Like I'm sure a lot of folks will go like just spend time just cruising Wikipedia, not necessarily just like systems, but you're like, oh, like how do boat engines work, or like, you know, what is my municipality doing to like provide sewer service and clean water service, right? So it's all of these things. I think to some portion of the population are fascinating, and the operating system and system software are you know, they're the municipal utilities that we in computing rely upon. So to some, they're not glamorous. You know, you're not running some fancy UI or anything, but to some of us, you know, you can appreciate clean water when it's given to you, and the effort and the care that goes into making that clean water available all the time, and troubleshooting when it's not there. So it's been an interest of mine for a long time. When I was on the Unix team at General Mills, it was something where, you know, I could find a niche in people who were interested in this stuff. When we had a problem, you know, you could go to the manuals, or you could try and get more information from the vendor. And once we got into Linux, there was certainly a lot more room there for when a piece of system software was misbehaving, or if you know, even if the kernel was misbehaving, you could try and figure it out. You know, I am not a Linux kernel developer, but there were times when it was like, oh, we're seeing this weird problem. I'm going to at least, you know, walk up to the source code and try and figure out what this thing is doing. So that it was kind of being interested in that stuff that made it easier to get my job done. And it was kind of a dream come true when I came here to join and was asked, hey, you know, do you want to work on LX? Do you want to work on this? And LX was, I think, kind of for me the perfect opportunity to work on this stuff. So the way that the system call emulation was kind of initially implemented in SmartOS and Illumos was when a Linux binary was making a system call. It syscall into the kernel. And the kernel would see that this was a branded zone, that this was a process that was meant to be running with the system call table. And as such, it would actually have a shared library mapped into that kernel's address space. And the kernel would vector out to that shared library to execute or to implement the system call that needed to be emulated. The point being was you could choose some handful of syscalls to be like, oh, like if you want to emulate a read syscall, you could just from the shared library call your native libc's read. So it made doing complex things pretty easy. So when we were doing the work initially on LX, a lot of it was all implemented actually in user space. So I kind of, coming into the project, it was still in kind of a pretty rough shape, but there was a lot of room for me to, you know, to make some mistakes and not have the kernel at risk because I'm in user space. It wasn't a license to be careless, but it was certainly for me, it was a softer on-ramp into, you know, doing operating system development. And as our effort on LX continued, we went on and we moved more of that into the kernel, and now most of it's up in the kernel, and kind of being part of that and getting to learn, you know, what some of the conventions were in Illumos for how do you do this and how do you know, avoid certain problems. LX was the perfect opportunity for me to kind of come into that space.
Isn't it also being a developer writing for the sysadmins later who just use the system, that you have this mindset of making it easy for them?
Yeah, I mean, there's certainly different expectations about like the interface that you would want, right? If you're trying to, you know, rather than serve for a general consumer, you've got a pretty constrained audience that you're writing for.
Yeah.
Having been in that audience, you know some of the things that you might want, or some of the things that, you know, maybe you personally aren't interested in having, but you know that, you know, giving people options to do this in one way or the other might help them down the road.
Yeah, and you know, it can make having your background as an ops person can make a big difference when you're designing the more low-level interfaces, in that in the end, I know I'm going to have this set of information available to me, and I want to use it to get this other information. and you can design an interface that makes sense from that perspective versus people that have only ever done like pure CS and programming often design the interfaces for, what makes sense to them as far as what somebody might need from the system.
Sure, and simply just in work ethic, I know that like there's, having been in ops, you get the empathy for like, when something you've done causes a problem, like you know the kind of pain that you might have inflicted there. So it's certainly an incentive to get it right the first time, and when you don't get it right the first time, to try and do everything you can to help someone out that has been put in a sticky place by something you may have done.
So what first got you interested in Beehive and getting even lower level than the kernel?
Well, so I'd been aware of Beehive, both in the Beehive effort, and then I certainly saw some chatter about Xhive, which is OS X's port of that, right? Mm-hmm. So I had seen some chatter there. I wasn't using FreeBSD at that point. I had used it as my workstation OS for a couple of years a while back, but I like didn't have a system that I was playing with it on. So for me, it was really when it became clear that we were going to port this into Illumos, that's when I really dove into it. So, that's how I got into it. I know it certainly was kind of, from the outside looking in on Beehive, it was certainly more attractive in terms of, you've got on the Linux side, you've got KVM and QEMU, and KVM is pretty purpose-driven. QEMU is, it's this Swiss Army knife of emulation, and SmartOS and Illumos have KVM and QEMU in them, but they're both very old. Like that porting work, I think, was done like 2011, 2012.
It's been a while.
Yeah, and both, they've not essentially been updated. There have been bug fixes and security fixes to the KVM and QEMU in Illumos, but they've effectively been forked for years and years and years. And QEMU, I mean, to its credit, is it can do full x86 emulation, right? You don't even need to be on a chip that has VMX or whatever AMD's technology is. It can do that. It can do ARM. It's an incredible piece of software, but it's really its focus is on being this huge blossoming emulation platform, which makes it kind of difficult to work on if you want a tightly constrained production virtualization platform. So in that way, the focus of Beehive was certainly very attractive. It was, we're going to run AMD 64 emulation on this platform. We want to run VMs. I think from what I've read, its goals appear very similar to what OpenBSD is running, where like at first it was just, hey, let's virtualize FreeBSD on FreeBSD, right? Like if we can run some other operating systems, that's great, but like tight focus on running something in that manner, not being a Swiss Army knife. So from an outsider's perspective, that was very enticing.
Well, yeah, one of the goals of Beehive was legacy-free, not bringing giant, complicated emulation code along. So no floppy disks.
Yeah.
There have been, I think, 2 or 3 vulnerabilities found in the QEMU floppy disk emulation over the years. And it's like, why did my 20-core VMs even have a floppy disk?
Yeah.
Yeah. Okay, so, but how much work was it to take the years-old port of Beehive and get it working on modern Illumos?
Well, so we received a set of patches from a company, Pluribus, who had ported Beehive to their, I think what they have is strictly speaking, still in kind of an Open Solaris port. I don't know. I don't know the specifics on that, but from what I've gathered, they're not so much, they've been pulling from Illumos or whatever, but their fork is closer to Open Solaris. So we got a set of patches from them, kind of both older from an Illumos Open Solaris standpoint and very old from a Beehive standpoint. I think we got those back September of last year. I got involved in October. And the first effort was to get like a KVM image that we had fired up and initialized to just boot on those bits, to get it to compile and get it to boot. That went, I mean, it was a challenge, but we eventually got it wired up and got it booting. There were a lot of kind of shortcomings there. The work seemed kind of half completed. So Beehive had support for multiple CPUs, but the port that we had never had there was nothing that would initiate additional threads to run those CPUs. So you could say, hey, create an instance with 4 CPUs, and they would be there, but they wouldn't be, and they'd never run. So it was just a single CPU machine, which was a little odd. So once we got that working and had it functioning, it became pretty clear that we needed to get it updated pretty desperately.
So I guess, yeah, what was the process like to actually get that old Beehive port caught up to current FreeBSD?
So that was a huge ordeal. At that point, it was mostly myself. I was working on it, and then Hans, another employee at Joint, were working on it. So we kind of split it up into Hans was going to focus on the user space side, and I focused mainly on the things that were in the kernel side of things. And he and I both took a different approach to how we were going to update the code that we were going to use. Hans went, and I don't know kind of how he inferred where in Beehive's history the port started from. I didn't spend a lot of time looking there because it looked complicated to me, but he found kind of a commit in the FreeBSD history that resembled where Pluribus had forked it from who knows when. And he started walking forward with the FreeBSD patches, applying those to what we had in our tree in terms of the Illumos Beehive. I took a different approach. Our target was FreeBSD 11.1, I think. Mm-hmm. I went and I took the sources for FreeBSD 11.1's Beehive and copied them over the top of what we had in our Illumos one, which, to its credit, had a bunch of if-defs, and the kind of the Illumos specific stuff was wrapped in if-defs, so it was clear where it was, what special cases were needed or were thought to be needed for Illumos. So I copied that diff over and then started sifting through it, and I think it took me a week of full-time work before it even compiled. And I'm not saying ran, just built without. It was a hell of a thing. It was a considerable amount of work. Kind of one big piece of it was, since Pluribus had done the port, the way that Beehive handled guest memory had totally changed. So they started leaning on the FreeBSD VM system. And we're calling a bunch of functions there that we just didn't have. So, I had to write a shim system to re-implement EPT and all of that. There was kind of a lot of shim work to do to get that up off the ground and running. Mm-hmm. A lot of kind of strengthening code, a fair chunk of code in there was worked in the optimal case, but in terms of wanting something that was production ready, we wanted something that would not panic the box in the malicious case. So spent a lot of time hardening that up. And in terms of, a lot of it was kind of Illumos specific or OpenSolaris specific. So that took, it was maybe about a month before we got that back from, booting a single CPU on the old bits to booting a machine on the new bits. And then after that, it was kind of a pretty long shakeout period in, once it was booting and working, applying load to it and finding bugs.
Yeah, I did a little debugging with Hans and Jorg and some other people at FOSDEM in the spring.
Mm-hmm.
Winter.
At the booth.
Yes.
Yeah.
We were getting a crash in the firmware. The UEFI
the
firmware.
UEFI. Yeah.
But it's interesting to see FreeBSD has this whole stack of shims to be able to run the Illumos code like dtrace and ZFS and so on. And then Illumos is growing this whole shim stack to be able to run FreeBSD.
Yeah. Fortunately, I mean, the VM system shims were kind of the biggest. Mm-hmm. But other than that, it hasn't been so bad. A lot of it has just been pretty simple, like, oh, it's called a different name and mm-hmm. has slightly different expectations around parameters. So a lot of the compatibility stuff isn't too serious.
Right. It's pretty thin.
Yeah.
Okay. So if I would install Illumos today, how usable is Beehive on it right away or right now?
That's what. So the work we've done. So the Beehive work has not gone upstream into Illumos. One of the other distros, the OmniOS Community Edition folks, have been pulling our Beehive patches into their distribution, as far as I know. On SmartOS, the biggest issue right now is image availability. So ideally, we ship KVM images that are ready for you to, you give it a VM payload of, oh, I want a VM with this many resources and these IP addresses on its interface, and it will come up and boot and be assigned those addresses and allow you to log in. We don't have a set of images that kind of function in that way that are published yet for Beehive. So in that sense, it's for someone to walk in off the street and boot a Beehive VM on SmartOS, it is not accessible. That said, we're doing a lot of testing internally. There have been some images published, or you can the way that we started was you take a KVM image and get it kind of set up how you want it, and then just swap it over to Beehive. It's just a disk image. So for those things, Beehive has been working pretty well. We've been driving hard load on it. It's considerably faster than KVM. One of our focuses has been network performance primarily. So like I think what exists in FreeBSD, we have a driver implemented to do VirtIO net in the kernel. It's kind of glued into our network stack. So in that regard, the network performance versus our KVM it's been great. There's still work to do on it, including work just in our native network stack. But that part has been working great. We've driven the CPU count up. I think in FreeBSD, the define that sets the sizing for VMs in FreeBSD is I think 16 vCPUs. For some of the testing we were doing, people were wanting more, so we cranked that up to 32, and it worked fine. We've leaned on it.
Our producer asked us to ask you about that because on FreeBSD, if you just turn it up to 32, then it runs into some other data structure and messes up the APIC table or something.
Didn't blow up on us.
Okay.
It might be that there are some differences on how we're allocating some of those structures, but it right. Didn't blow up at 32.
Okay.
So,
because I think if you go over 22 on FreeBSD, it runs into one of the other data structures and messes things up.
And I would like to see the details on that. I'd be curious to see if we just got lucky or have avoided
allocating one of those differently or what.
Yeah, there are. I think there are a handful of things we're allocating differently. That was.
I know it's been a goal for a while to change those to be dynamically allocated so that it's not a static define, because I think the reason why it's capped at 16 is that even if you start a bunch of VMs with 4 CPUs, it allocates the structure for 16. And, that can be a lot of overhead if you're running a bunch of virtual machines.
Absolutely. And looking at kind of what's been going on upstream, it looked like some of the CPU topology work kind of is alluding to, I think they had a max in there, so maybe that will be used to allocate those structures down the line. I don't know. It would be nice.
Yeah, because that was the topology work was interesting because by default, Beehive's like, oh, you want 32 CPUs? I'll emulate a system with 32 sockets with 1 core each. Sure. That's fine until you're running something that has licenses. Windows like, I won't boot if there's more than 8 sockets, or your Oracle software is like, You must pay me all of the money now.
Yeah. Oh yeah, it's a single 64 core CPU, one socket. Yep, definitely that.
Yeah.
But it's interesting to see. You mentioned that you threw a beehive and all the bees flew out, and now you have to make changes in other parts of the kernel, like the networking stack. So it all connects to these different parts of the system.
Yeah, I mean the networking stack work is work that we've needed to do. Bringing beehive in, when we're trying to squeeze the best performance out of it, it was clear to us, that there are improvements that we need to make, and it will help everything else in our system. But kind of this focus on networking performance has spurred that work into action.
So what area of beehive are you most interested in improving?
That's a good question. There are pieces that I think are perhaps specific to Illumos, and then there are pieces that
General.
I think would be nice for everyone. I have a pretty strongly held position about something that I don't want to see improved about beehive. The lack of nested vert support. While it's, I think, a pain for some people who want to test vert in a vert, I consider that a huge feature of beehive in terms of an easy to work in code base. Having poked around at what Linux is doing in KVM and all of the things they had to add for nested vert, I really hope that the decision is to not do that for beehive. Even if someone walks up with a patch that says, hey, I implemented nested vert and I tested it all and here it is, I think that will make it harder for all of us if we do that.
Yeah, I definitely beehive made the right decision with requiring hardware that does EPT so it didn't have to emulate it, and
yes,
choosing not to do some of those things just because, this is software we need to maintain with not a VMware-sized team, and so we don't want to have these features that are just too hard to understand and just too many fingers all over the code base.
Yes. Yeah, and it reaches into everything, and suddenly it's a mess. As for things I'd like to see in beehive, you touched on dynamic CPUs. I think it'd be nice that there are parameters that control like virtual interrupt delivery and kind of system level features that are turned off and on that, it might be nice to be able to toggle those on a per VM basis for testing. Kind of better just parameterization in general about, setting things like that. I think about what else.
Storage, maybe?
I have garbage disks in my test machine, so like disk throughput is not something I've tested. Like, I just can't, I've got like surplus disks in a machine that it's
right.
I could.
I know a feature people have wanted for a long time is support for other disk image formats rather than just raw disk, like QCOW and VMDK and so on.
Yeah, that would be interesting. I would assume that would just be kind of more kernel driven drivers for those PCI devices, right? That the implications for core beehive itself wouldn't be too serious. You just bolt on.
Yeah, the start of the project originally was a library in user space that just sat between beehive and the disk image and supported QCOW or whatever.
Sure. Yeah, and yeah, I mean a bunch of it is still done in user space today, right? Mm-hmm. For all of the things that aren't worth doing in the kernel. Yeah. Yeah, that would be. I know there's been some talk of migration. Like live migration or things like that.
Yes, there's some researchers at a university in Romania that are working on that. I've seen a demo of it working once.
Yeah, it is certainly interesting and I think would be useful and valuable and not so complex that it would be unlike nested vert. I think that live migration could be implemented in the same way. But it would be nice to have influence on that design to make it easy for, like we would love to have live migration in SmartOS and Lumos in our Upstack stuff in Triton. It would be nice if it was implemented in a way that both a home user that's doing whatever they want and us could enough hooks in it so that you could do it for a lot of use cases.
Right, because I think the way it's implemented now, it's probably a little specific to the FreeBSD VM stack.
Yes.
To do the memory tracking and so on.
Mm-hmm. Memory tracking and just like how do you serialize? I mean, you've got to move memory, but you've also got all this device state that you need to serialize and import into the other side. So, yeah. Yeah,
and even just when I know they're looking at ways to be able to, migrate to not an identical machine, but then eventually you get to the question is like, I want to be able to migrate from a FreeBSD beehive to an Lumos beehive.
I don't see any reason why. Well, if you generalize things like the TSC and parameters like that and have the appropriate scaling, I don't see why it wouldn't be possible.
This is actually a good part for the next question. Do you think that the FreeBSD and Illumos version of Beehive will stay in sync with each other over time?
I certainly hope so. It's, I think, in all of our best interests that be the case. I know that, so the initial port work that we did, we synced up to FreeBSD 11.1. Since then, we've done the second sync that we did, I put back just a couple days ago. So we've been pulling in changes that have been going on in upstream Beehive, right? Just bug fixes, features, what if someone wants to use the topology stuff, great. There's been work that we've done, either bug fixes or, if we get involved in features that we want that would be useful to the community. Absolutely, I'd love to see those go upstream. Everything that we keep in our branch in a diff is just a lot more work that we need to do whenever we sync from upstream. So everything that makes sense for upstream Beehive, I would love to see go upstream in a timely manner.
Yeah, this is the giving and taking that we want to see in open source, and which what attracts us to open source in the first place.
Yeah, there's no reason to do that work twice, right? It can benefit us all.
Is there anything else you wanted to touch on Beehive?
I don't think so. I think we've hit. I think we've hit it all.
Yep. So changing gears a little bit, what do you do for fun?
For fun, I do a lot of work. But other than that, now that it's summer, I've been enjoying getting out on the bicycle again. I'm not in the Bay Area. I'm in Minneapolis. So we do have 4 seasons here, and I'm not one of those people who goes out on their bicycle in the middle of winter. That isn't for me. So I stay cooped up. But now that it's warm again, and it's it almost seems like we went straight from winter straight into summer. But now that it's nice again, it's nice to be out on a bicycle. So.
Yeah, that's a nice activity. Is there anything else you want to mention before we let you go?
Not that I can think of. I appreciate your time chatting here.
Yes, we appreciate your time taking 40 minutes out of your day to talk with us.
Great. Thanks.
Thank you. So we hope you liked this interview. We have some news in our news roundup that might be interesting to you because people have asked us sometimes here and there, how do we set up a buildbot in FreeBSD? And that's what we have here, setting up a BSD jail with a buildbot in it.
Yeah, so the author says, in this article, I would like to present a tutorial on setting up a buildbot, a continuous integration or CI software, kind of like Jenkins or Drone or whatever. Making use of FreeBSD's containerization mechanism, jails, we will cover the terminology, rationale for both buildbot and jails together, and all the steps to install it. At the end, we will have a working buildbot instance using its simple build configuration, ready to play around with your own CI plans or even CD if you want to, which is continuous delivery where you validate the output, basically.
Yeah.
Some hints for production-grade installations are given, but the tutorial steps are meant for a test environment, like in a virtual machine or whatever. BuildBot's configuration and detailed concepts are not really in scope here. So a table of contents kind of give a rundown of what's available in the article. First, you'll choosing your host operating system and version for BuildBot, creating a FreeBSD playground, a bit of an introduction to what jails are, an overview of how BuildBot works, set up the jail, install the BuildBot master, run it, install a BuildBot worker, or more than one, and run those, setting up a web server so that you can access the BuildBot UI, run your first build, and then some tips for transitioning from test to production. So they say, we chose FreeBSD 11.1 release as our platform for BuildBot. There's no particular reason, and as a matter of fact, BuildBot is a Python-based server, so it's very cross-platform, anywhere where you can run Python. It'll make a difference for what you do with BuildBot. However, for instance, Poudre is the de facto standard for building packages from source on FreeBSD. Builds run in jails, which may be any FreeBSD-based version older or equal to the host. And they talk a bit about how that works. But in general, you can just install BuildBot and you're good to go. So in order to create their FreeBSD playground, they say Vagrant is a popular tool to quickly set up virtual machines from build images, and they're using it here for simplicity. Any form of test environment or virtual machine would suffice. If you choose to follow along using Vagrant, just install it and ensure you have a compatible hypervisor. So they just did Vagrant init FreeBSD 11, and then they had Vagrant up, Vagrant SSH, and they're in a working FreeBSD machine.
And you can see
they have a breakdown of what jails are, but you can look at that yourself if you still need help with that. And then an overview of BuildBot. Basically, there's a master, a component which parses all build configuration and other settings, like setting notification emails, changing sources like Git repositories, and so on, and then distributes those builds to actual workers. And then BuildBot worker is a dumb component which can be or can have a connection details, and it goes and does the work basically. So you can use BuildBot to orchestrate many machines doing your CI stuff, or you could set up each one to run single-threaded and use it to schedule. If you have 16 cores, you can run a separate jail for each one and have the master coordinate them and keep them all busy, whether working on different things or whatever. So they show setting up jails. They say they're cheap and easy and semantic. So they install EasyJail and just EasyJail create a couple of jails and they're good to go. And then they show using PF to set up NAT so that the jails will have access to the internet.
Oh yeah, important if you want to fetch some sources.
Forwarding port 80 into the BuildBot master jail so that they can do the web interface.
Yeah, there's also a screenshot there.
Yep. So then they just package install pi36-buildbot and the pi36 buildbot www, and that will give them BuildBot and the website stuff. Then they just run or make a BuildBot master user, create the directories, and run BuildBot create master on the directory, and it'll be good to go.
Yeah, it's very detailed, so you should not have difficulties following along. Well, great article. And well, if you want to build this on the internet, you should try this out on our second sponsor for this week, DigitalOcean, because they can provide you with droplets, that's little virtual machines, or maybe not so little virtual machines in the cloud, and they have FreeBSD support, so you can start FreeBSD jails or just your regular virtual machine in that cloud and run pre-built applications like a LAMP stack or a MongoDB or MySQL that you might want to run. And from there, it's pretty simple to start, and those droplets are instantly created within seconds. And that's just great to get something started pretty quickly. Let something calculate something or compute something, and then delete it again because you finished and got the results from that.
Yeah. So whether you need some memory, some CPUs, or just some transfer and storage, they have all for you. I really like their flexible droplets where you can choose how much memory and CPU you want, and you get 3 terabytes of transfer is probably more than you need. And $15 a month makes you can run pretty much whatever you need with 2 gigs of RAM, 2 CPUs, and 3 terabytes of transfer. Last week we talked about how to run a FreeNAS on DigitalOcean, and next week we're going to show you how to run a pfSense. Why would you run a pfSense in the cloud? Hey, look, you now have a VPN endpoint.
Yep, you can do interesting things with that.
How much for a VPN service when you could run a VPN yourself for less?
Yep, and with those transfers, that's pretty much a done deal for you if in case you're on the road or connecting from a remote place to your company or from a hotel. That's a good use case for that. You could also back up, of course, your little droplet in case something goes wrong and create snapshots of those, as well as share those droplet management with the team functionality they have, which is cool.
Yep. And using the floating IPs feature, you can get a separate public IP you can move between VMs so that you can keep your important service online, even if you need to take nodes down or whatever.
And for programmers,
upgrade time.
Yeah, eventually it's there, yeah, and then you want to be prepared. And for the programmers, they have an elegant API for for Ruby, for Curl, for Go, or they have their own DOCTL, their DigitalOcean control panel, where you can spin up machines like in the thousands in case you need those.
DOCLI is super easy to use command line stuff. We use it all the time.
Yeah, it's just great, and you can start trying out DigitalOcean with our coupon code FreeBSD Now, which gives you a $10 credit. And I think we still have the other coupon code.
If you go to do.co/BSD Now and sign up there with that secret URL, you'll get $100 for 60 days to try out DigitalOcean.
At the fullest capacity, yeah.
Mm-hmm. That's, you can have lots of fun playing around. You can get a pretty big instance for that amount of money.
Yeah, or multiple small ones to work together in some kind of MongoDB cluster or some other things you always wanted to try out but don't have the machines for.
Yeah, that's another great use of it. It's just, I want to play with that Mineo thing we talked about the other week. And you need, it's like, I need 3 nodes or 4 nodes each at 3 different data centers to do that. I could possibly try to do that on my laptop, but I think I would run out of RAM. Whereas if I use DigitalOcean droplets, spinning up a dozen 1 gig droplets isn't going to take all the RAM on my laptop.
Yeah. Plus, you can see how the transfer speeds are between the different data centers and locations.
When you have multiple gigabits per second of internet coming out of each of the droplets, that makes a big difference compared to my desktop. And the cheapest droplet is only 0.7 cents per hour. So if you're just going to spend your Sunday afternoon working on this, you're going to have a hard time spending a quarter.
Yep. And if you don't like it, then just switch it off and you don't get billed anymore. Then you used. It's just the usage time.
Yep. Okay,
all right.
Next story.
Yep. We have dumping your USB, which sounds like throwing it away, but this is about the USB traffic on OpenBSD. So it starts over at grenadille.net. One of the many features of OpenBSD 6.3 is the possibility to dump USB traffic to user land via BPF. And this can be done with TCP dump by specifying a USB bus as interface. So you're not specifying your network card this time. You use the USB bus interface. So this is TCP dump dash capital X, lowercase x, dash I for the interface. And there you provide your USB 0 in this case. And then it starts talking to you, not networky things, but USB interface traffic. As you might have noticed, the author decided to implement the existing USB PCAP feature format, which is a captive format required because USB packets do not include all the necessary information to properly interpret them. That first thing looks like it would implement the PCAP's DLT_USB, but then the author quickly realized that it was not a standard. It is instead a FreeBSD specific format, which has been there since they renamed it from DLT_USB FreeBSD. So looking at the existing formats, there are a couple of those, one for FreeBSD, one for Linux, one for Linux M-mapped, Darwin for not Windows, Mac OS, and DLT USB PCAP. And the choice was to pick the simplest one is the USB PCAP. So implementing an already existing format gives us out-of-box support for all the tools supporting it. That's why having common formats lets us share our energy. In the case of USB PCAP, it is already supported by Wireshark, the popular application, so you can already inspect your packet graphically. For that, you need to first capture some raw packets, which can be done by TCP dump, and then you write that out into a PCAP file, which Wireshark can then read. And the USB packets can be quite big, but that's why here we are not using TCP dump. The default packet size, because in this case, we want to make sure we can dump the complete U-audio frames. So from your USB audio, we just want to listen on the wire in this case. And once the capture is complete, time to look at it. So this is a little screenshot from Wireshark. And it's important to say that what is dumped to userland is what the USB stack sees. So packets sent over the wire might differ, especially when it comes to retrieving and timing. And this feature is not here to replace any USB analyzer. However, they hope that it will help people understand how things work and that the USB stack is doing and what its internal state might be. Even when I found some interesting timing issues this way, they finally implemented isochronous support. Yeah, so it's interesting to see that TCP dump cannot just capture packets from the network, but also USB traffic. Very nice.
And lastly, we now have configuring OpenBSD HTTPD for your web server.
Oh yeah.
So as you see, as soon as right, so after you install OpenBSD, as soon as you're there, you can enable the web server just by editing the config file, adding some server sections pointing, say what IP and port to listen on and what root directory to use or how to redirect the traffic. They make a document root and then do httpd-n to do a syntax check. Then they used rcctl to enable and start the daemon. And if you go to the address, you now have a web server.
Oh, that's quick and easy to start that.
Then after that's done, you can switch to having HTTPS.
Of course.
So for this, you're going to need to issue some certificates with Let's Encrypt. So they show how to configure Acme client and get that going. And then you add the configuration block to your web server. Once you have the HTTP or the TLS certificate, you just add TLS with your certificate and key and listen on IP TLS port 443. And now you have HTTPS on your web server.
Yep. That's all detailed with the configuration files and commands that you need to enter to get that running. And you can find some links to other section in the blog that talks about similar things.
Yep.
Very cool. And we have modern, Akonadi, and Kmail on FreeBSD. So this is for the KDE folks out there. Here we have basically written down for quite literally a year or more, Kmail and Akonadi on FreeBSD have been only marginally useful at best. KDE 4 era Kmail was pretty darn good, but everything after that has had a number of FreeBSD users tearing out their hair. Not me, but yeah. So sure, you can go to that one, which has its own special problems. Trojita, what's it called? Yeah. And it's generally or bail out entirely to webmail, but Kmail is a really great mail client when it works, which on Linux desktop is nearly always, and on FreeBSD nearly never. Okay, I looked at it with Dan and Volker last summer briefly, and we got much further than, There's a message about the world is going to end, which hardly makes sense. It means that a message has been truncated or corrupted while traversing a Unix domain socket. Now, Alexander Martins, praise be, has wandered in with a likely solution. KDE bug 381850 contains a suggestion which deserves to be publicized and tested. So this is sysctl settings?
Yeah, so it's changing the buffer size on the Unix domain socket up to from 8K to 64K.
So a little bit more.
Which is the size that Linux has by default.
Okay.
While that works around the problem, it seems like the problem is that KDE assumes everybody runs Linux.
Yeah, the Linuxisms. But, okay. As long as it's just a simple sysctl change. Okay. So that's what it says here. Bumping up to 64K. And no other changes, no recompiling, just bumping the sysctl, and Kmail from Area 51 hums along all day without ending the world.
And I think we're pretty close, if not already, to the point where you don't have to run it from Area 51 anymore. It's available in the real ports tree.
Yep, porters are busy. This is a big piece of software, so it takes a couple of time and effort. But since changing this value may have other effects, and Akonadi shouldn't be dependent on a specific buffer size anyway, they're looking into the Akonadi code, encouraged by Dan, to either automatically size the socket buffers or to figure out where in the underlying code the assumption about buffer size lives. So for now, sysctl can make Kmail users on FreeBSD happy, and later they hope to have things fully automatic. And if it doesn't pan out, well, package message exists. Okay, so there's a PS down there. Modern KDE personal information management applications, Akonadi, Kmail, which live in the desktop utils category of the official FreeBSD ports, were added to the official tree April 10th, so you can get your fix now from the official tree. Excellent. Thanks for the porting efforts, KDE team on FreeBSD. So, time for BSD Bits this week. We have package-provides support for DragonflyBSD, which was written by Rodrigo Osorio.
Yes, so Rodrigo brought over that work, so it's available on Dragonfly as well.
Oh, excellent. So it's a short message here.
Dragonfly 4.8, 5.0, and 5.2.
Oh, great. So people can, who are not on the very latest one, can still use that tool. Which is nice. So you can see which file came from this port, or from which package came this file from. So,
yeah, well, usually it's, I need this file, which package has it? But
yeah, yes. The other way around. Okay, yeah, thank you, Rodrigo, for porting that over.
Yeah. Then we have a blog post here. Memories of writing a parser for man pages.
Ooh, sounds like
by Roberto Dip, and it's interesting to read his thoughts on writing something that can actually parse man pages.
Oh yeah, and there we go with the grammars and parsing and macros and oh yeah, that's a great little read.
Yeah, especially if you're interested in man pages. And I think this one was actually taking the man source and making pretty web pages out of it.
Okay, because they might turn people into man page readers.
Mm-hmm.
Yeah, why not? And if you're more for the video watching kind of entertainment, let's say, you can find Brian Cantrell's interview over at Developer on Fire podcast, which is interesting to watch.
I don't think there's video.
Oh, it is? It's audio only?
It's an audio podcast.
Okay.
But still, another hour of Brian Cantrell, if that's your thing.
Mm-hmm. Because if you have watched any episode...
Brian's opinions on formal computer science education, a little bit about what Brian does at Joyent and what Joyent does, Brian's thoughts on the economics of on-premise computing and the collapse of its use in the face of the public cloud, Joyent's approach to openness and preventing vendor lock-in, how Brian got started in software, Brian's story of failure and attitude towards defects and the impact of personal confidence and so on, the pitfalls of having a fixed mindset among gifted individuals and the importance of persistence and so on, and also includes Brian's book recommendations, which are interesting. He recommended The Soul of a New Machine, which I've read and I can also recommend if you're interested in, how we got where we are in computers in the early days. That's definitely interesting. But also The Making of the Atomic Bomb. Dream Reaper, the story of an old-fashioned inventor in the high-tech, high-stakes world of modern agriculture, and so on.
How long does that go? Over an hour?
Yeah. And the bug count also rises.
Oh, yeah. That famous memo.
But I say Brian's 3 tips are read more, write more, and be persistent.
Okay. We'll heed that. Next up is I give you some dates and you do the math. So 25th of March 1978 to 25th of March 2018. Yes, 40 years of BSD mail. On this day in 1978, Kurt Schoens placed the following comment in dev.h. The fork I maintain keeps it in nail.h. This is from Stefan Meso. This is mail, the mail program on Unix.
Yeah,
that's when it started.
Mail program.
Mm-hmm.
It was written at UC Berkeley, and the initial commit went in on March 25th, 1978.
Wow. Here we go. That's how long mail, how old mail is and where it all started, at least from the BSD side. Yeah. Okay. Impressive. 40 years is a long time, definitely. A little shorter time frame is our next item. My 5 years of FreeBSD gaming, a compendium of free games and engines running natively on FreeBSD for the gamers out there.
Yeah, lots of different things with Westnoth, Zonotic, Warzone 2100, Warcraft 2. Played too much of that growing up. Unreal Gold, which I think I saw on Steam for free the other day. They got some car racing, Torx, Super Tux Kart, obviously. Light, and lots more. That's no wine, no emulators, just
XCOM,
open source, native running games. So if gaming on FreeBSD is interesting to you, you should check out their picks. They have quite a few different games there.
Mm-hmm. Yeah, so let the games begin. But if you're still with us, we have sequential resilver being upstreamed to FreeBSD from FreeNAS, where it was ported from ZFS on Linux. So this was this is history.
I think only part of the resilver improvements, but the big part, basically, where scans blocks and tries to construct them into useful ranges, and then when that fills up, flushes the largest range. So it definitely improves the speed of resilvers by doing more contiguous I/O in a straight line and less having the hard drive jump all over the place.
This reminds me of the old scan disk from DOS days. Rearranging. But yeah, Scrub is different because ZFS has a different data structure, of course. But it's good to see from the preliminary numbers they provided in the review that it's a significant reduction in the scrub time.
Yep.
Okay, so last but not least is the University of Aberdeen's Internet Transport Research Group is hiring. So if you're interested in doing research, then you might check out the two job postings that we have here. And these are research fellows and one research assistant. And you can find the details in the links in the show notes. And yeah, why not apply for that?
The closing date for that is... Where did I go here?
Soon. It's on the job listing.
June 7th. So if you'd like to work on internet research, you really should.
Mm-hmm. Yep. University of Aberdeen, Scotland.
Yes. A, Scotland is great. And B, you get to work on the internet. And the research assistant position is, designed for people that are just starting out, really. Available topics include large-scale active measurement of mobile platforms like 3G and 4G and so on. But they say all applicants must have a background in TCP/IP network stack, network measurements, and be proficient in programming in C or Python. You're expected to have knowledge of Linux and BSD operating systems and network stack principles, and understanding of software development is desired for some activities.
Mm-hmm. Okay. If that's your thing, then why not do the next great internet extension? Before we go into our feedback and questions section, we should mention a sponsor for that part, which is Tarsnap, of course, the online backups for the truly paranoid. When was your last backup? If you can't remember, then it's not a good sign.
Yeah,
you should regularly make backups.
You don't think about your backup until you need it. And when you need it, it's already too late.
Yeah, then you say, oh, I should have done a backup earlier and
with
regularly.
Tarsnap, it couldn't literally be easier. It's one line of command, and you'd be like, take these files and put them over on the cloud, encrypted with this key. And then you just do incrementals to that. And then at any time, you can be like, I want those files back. And as long as you still have the key, you're all good. And if you don't have the key, you get nothing. And that is how it's supposed to be, so that anybody else that doesn't have the key can't get your files.
Exactly. And it's just as easy to use like tar. If you know how to use tar, then Tarsnap is just an extension of that, basically. And you can find clients for Linuxes of this world, the BSDs, macOS, and the Windows subsystem for Linux. And you can also look at the source code if you are still a little bit suspicious. Check it out.
You don't have to look at the source code, but would you trust any other backup tool that didn't give you the source code?
Maybe they're doing a little backup for themselves, move it somewhere else where it's been scrutinized for something. But in Tarsnap, it's locally encrypted before it goes into the cloud. So you
it
are
only
the
takes
key holder.
$5 to get started. So just go try it. You'll be as hooked as we are.
Yeah. Okay, time for feedback and questions. That's the part where you interact with us, basically, and we answer your questions. The first one this week is Dave about mounting non-file system things inside jails. That goes, hi folks, I'd like to remove the need for an RFC 1918 jail IP from my jail systems by using Unix domain sockets to connect the jailed web server in a jail to the host system's proxy servers, H8 proxy or Nginx, outside the jail. What I'm not clear on is that for the proxy server to run, it needs the Unix domain socket already created. And I can't rely on the jail being available at boot time yet, and I'd like to be able to restart the jail without needing to restart the proxy servers each time, as the socket would be disconnected. What options have I got here?
Well, like, normally the socket doesn't have to exist. Like, Nginx won't try to connect to the socket until somebody connects to Nginx and wants to go to that socket. So that should still work. I don't know if H8 proxy is different in that it tries to keep the socket open all the time or something. But definitely with Nginx, you don't need to do anything. Just in the Nginx config on the host, you just say your backend is here and give it the full path to the jail, like, user jails, jail name / var run nginx.sock or wherever you put your Nginx socket, or whatever socket is inside the jail. And Nginx won't really be poking that until you make a connection and try to have Nginx, proxy something to that.
At first, when I read the description, I was like, we were trying to mount something from outside the jail into the jail, but this is now more.
But yeah, like if you needed to do that, nullfs would have let you take a directory
and mount
on
it
the
into
host and expose it into the jail so that the socket could be somewhere where. So socket created on the host, although you didn't have to do that way either. If you were trying to do this the other way around or something, you would just have the program create its socket in the jail's directory somewhere, and then just in the jail access it by that relative path.
Yep,
so
that should do it.
As far as I know, it should be fine the way it is. Like you should just be able to point to the socket in the jail. Also, even during a restart, usually the socket file will still be there. It just won't be connected to anything yet.
Yeah, it's just waiting for the first connect.
Yeah, so maybe you'll need to write back with an error message about why it's not working, because maybe there's something else going on.
Yeah, there may be something missing that we...
If the proxy server on the host is Nginx, you definitely can point to a socket that doesn't exist yet, because it doesn't connect to the socket until you make the first connection to the proxy.
Yeah, because otherwise it would just waste resources.
Like, I think even without jails involved at all, my Nginx uses a socket to talk to the fastCGI, and fastCGI doesn't start till after Nginx is started, and that works fine.
Yep. Okay, maybe that's solved
maybe
already.
There's more going on there, or maybe they just assumed it was going to be more difficult than it is.
Possibly. Okay, next up is Morgan with a short message telling us about what we covered a couple of episodes ago, the ZFS on Linux data loss bug. And there's the link to the GitHub issue we covered. But when we covered it back in those days, let's say, they weren't close to a solution yet, but now apparently this one is closed. So do you know anything more about this?
I know that they were working on this stuff. There was some discussion about it when I was at the ZFS user conference.
So it seems like Brian Behlendorf closed that one. So it seems like they are close to a solution or have found one.
I'm just trying to scroll through it here, and we didn't.
Yeah, so these were the files disappearing, and there's an upstream. Oh yeah, there's the regression. Yeah, they closed the one. The downgrade to 0.76 of ZFS on Linux was needed, and then they could provide an upstream version that fixed that, so people can upgrade then. This is Linux only. ZFS people on other operating systems don't need to worry yet, at least not that we know. Okay, thanks for letting us know about this again, so we could revisit that. And next is Renee. How to keep your ISP's nose out of your browser history with encrypted DNS. This could also be a talk, by the way. So this message goes, hi, Alan and Benedict. Perhaps you already covered this as I'm a bit behind. The below article is about using Cloudflare's 1.1.1.1 or other providers for encrypted DNS, like DNSCrypt or DNS over SSL HTTPS. This is over at arstechnica.com. Giving you an introduction.
I think we have a tutorial on our site about using DNSCrypt even.
Yeah, could be. This is more like how-to style, or just a description how to...
We have one from 2014, Encrypting DNS Lookups, and it's a tutorial of how to set up DNSCrypt. So
Yeah, so that no one can.
If you want to do that, and you
or
can set the upstream in your DNS script to be something like OpenDNS or the Google DNS or whatever. I personally would avoid the Cloudflare one, but that's just me.
Oh, that's a personal preference, but in general, there are ways to let your ISPs close
also
out
a
of
problem
those.
with the Cloudflare one in that because they don't do eDNS client subnet for privacy reasons, you'll get worse performance from a lot of things that use CDNs because you'll be mislocated.
Okay.
Anyway.
All right, and last but not least is Rodriguez with a feedback question for Windows Yesterday. That's the other show. No, it's a question relating to Windows, so let's try us to answer that. Just this once. Okay, so hello, Alan and Benedict. I'm currently someone who is learning information systems. I have a home lab set up and in the running for a few internships. Okay, cool. In relating to BSD, specifically FreeBSD, I have some questions up how well there is interlooping and integration with a Windows environment. In this case, I'm asking specifically about, first, Active Directory, registering and using a FreeBSD machine to an Active Directory.
It's used Samba to do it, and so you install the Samba package, and there's tutorials on how to join the domain and be able to log into it with the Windows Active Directory usernames and so on.
Yep. We have something at the university in our computer science department. The whole university is using Active Directory, but we have something built with OpenLDAP, so we don't have to run our own Active Directory servers and things like that. And it's basically just LDAP logins on FreeBSD. Second is SMB and file sharing, specifically with ZFS, of course, because I love how wonderful that file system is. You're not alone.
Yes. So again, Samba, which you'll already be running to join Active Directory, provides the SMB file sharing features, including if you enable a feature in Samba and name your snapshots just right, the snapshots will show up in the on the Windows machines as volume shadow copies, so that users will be able to access snapshots and get old versions of their files back.
Yeah, don't try to mess with the share SMB option in ZFS. That's not actually implemented in FreeBSD. You have to use the Samba functionality. Third, Office 2016. There isn't much that a non-Windows machine can do here. I know that, but there are things such as Exchange and SharePoint that that would be nice to be working with FreeBSD.
Well, there's not really a way to do that. You can run a different mail server on FreeBSD, but if you want Exchange or SharePoint, you pretty much have to run that on Windows. You could run it on Windows in a beehive on FreeBSD if you really wanted, I guess.
Yeah, but that's just clear missing support and all that. Number 4 is management of Windows machines. I'm not looking at full SCCM, but something to monitor. Well, there are all kinds of monitoring packages on FreeBSD for
if you want to use
kinds of
Basinga or Nagios or Cacti or whatever, you can definitely monitor your Windows network.
That's totally and well supported.
For your first and second question, Samba is the open source package that will turn any FreeBSD machine into being able to be compatible with your Windows network. For desktop-y Office stuff, obviously you can use LibreOffice or whatever, or if you happen to be using the Office 365 cloud thing, then suddenly you replace all your Office software with your web browser, and it doesn't matter what operating system you're on.
Yep, but I like the approach that you want to integrate FreeBSD with the Windows and don't want to miss out on the features that ZFS provides. And
if you just want it as a file server, FreeNAS has all the goop simpled down so that you can just use the web interface, join it to your domain, and make it so that you can use Windows permissions on all of the files on your file server.
Yep, they've done all the heavy lifting for you.
FreeNAS is meant to integrate into Windows very nicely. It's how we insidiously get our start. Get a little bit of FreeBSD in the network, and then it's more and more and more and more.
Yeah, and suddenly it's all BSD. Okay, that's the end of this show. Again, if you have any questions to us, comments, found a cool blog post or article about BSD that we should cover, then send that to feedback@bsdnow.tv and we'll cover it in a future episode. Thanks for watching.
See you next week.